Hello everybody! Welcome to the design overview of my Beetleweight combat robot, Akatsuki. Before the details, an important clarification. This robot will be competing in Europe and the United Kingdom, so it is designed to fit the 1.5 kg weight limit. It is currently in the process of being built, so everything showcased in this video is subject to change. So with that out of the way, let's get to the design. Akatsuki is a 4-wheel drive vertical spinner featuring a decently wide wheelbase with a bar-style weapon. The effective diameter of this weapon is 140mm at a 6mm thickness. The material is laser-cut Hardox 500 and it features 2-axis asymmetry. Let's take a look at the weapon from a little bit closer. Here we go. This is the weapon isolated. This is the side profile of the weapon. It features quite a big rake angle. This is to maximize bite and engagement from this weapon. As you can see also on the backside of the tooth, I have a pretty big fillet here. This is to minimize the chances of horizontal spinners catching the back of this weapon. Let's take a look at the rest of the bot again altogether. As you can see, the weapon sits between these two pieces here. This is a 3D printed pulley. This will be printed from nylon. Same thing here on the weapon motor. Both of these will be printed out of nylon. And this is to hold all the nuts for the 6 screws that hold the entire weapon hub together. Inside the weapon hub, there will be a needle roller bearing, and maybe you can see there are washers on either side of the weapon hub. The weapon will sit on a 10mm diameter weapon shaft, one that I will show off right here. As you can see, it just goes right through the entire thing, being constrained by these two caps. This is to avoid any issues with the weapon shaft potentially tearing straight through these uprights. I will talk a little bit more about the uprights in the chassis segment of this video. Now let's take a look inside of the robot. For spinning the weapon mentioned earlier, I have chosen a U-Angel 2807 drone motor, specifically the 1500 kV variant. As you can see, it sits on this aluminum mounting plate attached to the right hand side upright by 4 of these standoffs here. Let's move on to the drive system for the robot. As you can see, the drive motors sit here at the back, driving the back wheels directly. For the drive motors, I picked Cascadia Fabrications GXP24A gearboxes with their EC1806 motors. The 4-wheel drive system will be achieved via belt drive from the directly driven rear wheels to the front. Something quite neat that I would like to show is the set screw hub hidden inside of the rear wheel pulley. This is to maximize power transfer from the motor to the rear wheels. For the power of this robot, I have chosen an 850 mAh 4S LiPo battery. You might notice that there is no switch, there is no link on this robot just yet. The reason for that is in here in the EU, some competitions allow switches, some competitions require links. I have not signed up for any competitions yet, so I have not decided on which one to implement for this robot. I have quite a long ways to go until I actually wire up everything and need to decide on a solution, so for now, I decided to leave that as future me's problem. Now, let's take a look at the construction of this robot. For that, I wish to isolate the chassis to talk a little bit about that. Let's give it some time. Here we go. Now, here is the chassis. It is designed to fit on the print bed of a Creality K1. That is the 3D printer that I have. This chassis will be printed out of TPU as one single piece. Some of the features, as you can see, 3 of the 4 fork mounts here on the front. the hole in the right hand side upright for the weapon motor to pass through, space here to route wiring between the two halves of the robot, some insets here. These are for the magnets on either side of the robot. Of course, I will only run magnets if the arena floor allows me to, so no magnets on wooden floor. And a little bit of an inset for the battery itself, just to be sure that it will fit within the chassis. Now let's turn everything back on. Top panel included. We won't be looking at the internals anymore of this robot for now. As you can see, let's talk about the armor for now. As you can see, the fourth fork mounts are attached to the side panels. They're decently thick. Let me get you an exact value. At the top, they are 9mm thick, and at the bottom, they are 16.771mm thick. I would say that that's decent enough for a side armor on a vertical spinner. I have a 15-degree angle on the sides, as you can see from the front, especially. This is to prevent the robot from getting stuck on its side, and hopefully to minimize bite from other spinning weapons. Another feature I would like to note here is these two removable kick plates. These two, they're designed like that because, well, if I were to 3D print the entire chassis in one piece, that would mean that these kick plates need to be lower than the rest of the chassis, and it would need an ungodly amount of support material under it. This is the number one reason why I have picked this method for these kick plates, but also, just in case they get damaged, I can just swap in a new pair. Next up, I would like to go over some setups of the robot. We don't need to go anywhere just yet, as this is the main setup of the robot, only with the belt guard that might have been in the video previously. So, a quick overview. As you can see, all of the setups will be featuring the same weapon, and this setup has 4 decently long forks, as you can see. Here's a side view of the forks. Yeah, they're decently long. And side armor as well. This setup is meant to fight pretty much any other vertical spinner, egg beaters, drums, anything like that. Do note that these forks can be arranged in any variation. Another disclaimer here is that I don't have the exact amount of weight I have left for forks. By my calculations, 4 I should be able to get away with. If I have weight for more, of course, that will leave the option to run more forks open for me. Next up, this setup is for fighting control bots. This setup gets rid of the belt guards and the side armor. Of course, I would get rid of these standoffs and these screws as well, but we are in CAD, we can leave them for now. This setup retains the ability to have the maximum width mounts for the forks, while freeing up some weight for potentially more ground game. The lack of side armor here against control bots, side armor is not only unnecessary, but it can get the robot stuck in rather unadvantageous positions, so I solved that issue by getting rid of the side armor completely. If I were to fight a top attack robot such as a hammer or a hammer saw, I could keep the belt guard on to keep my belt safe from those top-down attacks. Next up, the anti-horizontal setup. It has quite a big wedge in the front, is rather wide, covering the full width of the robot. And it has a lot of screws attaching it to these 2 TPU blocks underneath it, which just slot into the fork mounts. And there is a pretty neat trick that the setup can do. It could have some sacrificial forks just in case I'm fighting a horizontal that happens to have some ground game. These are not the actual forks I would run, I just had them here as a bit of a proof of concept, but it does the job to illustrate what I mean. Next up, my full face piano key setup. It's 2mm steel plates screwed into TPU mounts. These mounts are meant to be TPU, and they're meant to be even more flexible TPU than the chassis is. Well, hopefully a lot more flexible TPU. And you might be able to see, if I go into top-down view, that it is clipping into the chassis here. That is to make sure that the TPU would bend and put as much pressure on the front of the wedge that's here as I can, because ground pressure matters a lot for ground game. Hopefully this would give me a bit of an advantage when it would come to that. This setup will not be made just yet. It would require a lot more laser cutting and a different type of TPU filament that I do not have right now. If I were to build this setup, I would use this against robots that have long forks, probably with robots that have long TPU forks as well, maybe even TPU wedges. Anything that I feel wouldn't have as much ground pressure as these piano keys would. These piano keys have a pretty big advantage of being able to be combined with forks from previously shown setups. Also, the side armor can be lost in favor of the normal lightweight fork mounts, so this would work, I feel, pretty decently against control bots as well. But as I said, for now this setup only remains in the CAD. Now for some closing thoughts on this project so far. Ever since I learned about combat robotics, I wanted to design my own machine and compete. This robot is currently in the process of being built. I will make a video on the process and my experiences building it once it's done. However, do note that this will probably take quite a bit of time. I am building this bot in my free time. I don't have any deadlines, I have not signed up for any tournaments just yet, but rest assured, the moment it's ready, I will be there no matter what. As a final note, I would like to mention 2 robots and a channel that inspired me the most during the design process. Fragment X from Shadow Combat Robotics and Endgame from Robot Rampage. As well as Team Embarrassing Engineering, whose videos helped me get started with designing this robot. I left links for all of these channels in the description. Stay tuned for the update, and thank you for watching.